Hello everybody, and welcome to exercise 2 on page 61 of the workbook. And this is going to be our first example of doing an iterated integral in a situation where we're integrating over a shape that's not a square. So notice that they're giving us a triangular region R to the right here, and they'd like us to calculate the integral of 6xy in two different ways. Once in the dy dx order and once in the dx dy order. Okay, in this video we'll be looking at just part A of this. All right, so how do we do this? Well, let's start with the integral that we're trying to calculate. Okay, and notice that they're telling us to go in the dy dx order, which means that our integral is going to have this basic form to it. 6xy dy dx. And the big question here is, what are the limits of integration going to be? Okay, so we're going to do what we did in the last example, start with the integral on the inside, which in this case is the integral with respect to y. So we have to decide what are the limits in the y direction for this function. Okay, well, let's take a look at our picture. You might look at this and notice, oh, our picture starts at the bottom down here where y is 0 and it goes up to 4. So at first glance, you might look at that and say the y limits must be 0 to 4. Well, I would agree with you if we were looking at the very right-hand part of our region. But is that 0 to 4 range true everywhere? Okay, it actually isn't, because we could, for example, start somewhere in the middle if we wanted to. Think of drawing a little rectangle which indicates the integration in the y direction, and the height of that particular rectangle is not 4. And in particular, depending on what point we choose, the height of this rectangle is going to change as we move along this line. So to make a long story short, our y limits are going to change depending on where we're at in the region. Okay, in particular, to figure out what those limits are, we actually need to know what the equation of this line is. Okay, and we can figure that out just by thinking about slopes here. So we're starting at the origin and we're going through the point 2, 4. So rise over run would be 4 over 2, which means that the equation of this line is y equals 2x. Okay, now what about, that kind of describes the top side of our region. What about the bottom side? Well, down here, y stays constant. Y is equal to 0 everywhere. Okay, so what that means then is that the limits of integration in the y direction, let me get rid of that line there, are going to be 0 to 2x. Think of it as integrating from the line on the bottom, which is y equals 0, to the line on the top, which is y equals 2x. Okay. And so now we're ready to think about the limits of our x variable. Okay, and here comes kind of another key step in a problem like this. Okay, so the way you want to think about your limits in the x direction is we have finished integrating in the y direction, so we are done with the y direction. So we want to think of taking this triangular region and simply letting it collapse into the x-axis. What do I mean by that? Well, to help you picture this, imagine shining a light straight down on this region and asking, what kind of a shadow would this region cast on the x-axis? Well, this light that you're shining down is going to get blocked by this triangle, and the shadow that you're going to get is just this line right here on the x-axis. Okay, and where does that start? Where does that shadow start and where does it stop? Well, we can see that x equals 2 is on the right and x equals 0 is on the left, and so our limits have to be 0 to 2. We got those limits by just shining down a light, looking at the shadow, and then writing down the x values on either side of it. Okay, so there's our integral. That's what we need to calculate. Let's see if we can do it. Okay, so as we did in the example above, we're going to start with the integral on the inside. Okay, we're integrating with respect to y, so we need an antiderivative of 6xy with respect to y. Remember that when we do that, we're treating x as if it were a constant and just integrating with respect to y. Okay, so let's see, we're going to get 6x. Antiderivative of y would be y squared over 2. And then we're going to evaluate that between 2x and 0. And I want to remind you that those limits are values of y. So I'm going to write y equals 2x and y equals 0. Okay, and then we've still got a dx at the end of all of this. Okay, and we can do a little simplifying here. If you look at this function, 6 over 2 is 3, so this simplifies down to 3xy squared. Okay, so if we rewrite this integral, it looks like the integral from 0 to 2, 3xy squared evaluated between y equals 2x and y equals 0 dx. Okay, so we're going to take those two limits of integration, substitute them in for y. So we're going to get 3x times, let's see, if y is 2x, we're going to get 2x squared minus the lower limit, 3x, now y is 0 squared. Okay, so we wind up with that integral. Okay, continuing. If we simplify 3x times 2x quantity squared, we are going to get, looks like 12x cubed. And now we're down to just an integral that has x's in it. Okay, and this is an ordinary Calc 1 integral. So if you take an antiderivative for 12x cubed, you're going to get 12x to the 4th over 4. That's just 3x to the 4th, evaluated between 2 and 0. Okay, and you plug 2 into that, you're going to get 16 times 3 is 48. And there is our answer. That is the value of our integral.